Hello everyone, class 12th topic is saytzeff rule versus Hofmann rule in beta elimination reactions of haloalkane. Let's try to understand it. One side I am writing saytzeff rule and one side Hofmann. Let's check what is the difference between these two rules. Haloalkane with beta hydrogens and strong base, condition for beta elimination reaction, and we know what will happen. In previous videos we have understood this beta elimination reaction. Suppose this hydrogen and this X is eliminated, bond will generate between these two carbons and the alkene will be this. This one. And suppose if this beta hydrogen is eliminated and this X is eliminated, bond will generate between these two carbons. Alkene will be this. Out of these two alkenes, this is more stable. This is less stable. So saytzeff rule is saying less stable alkene will be minor product. It is minor product, and more stable alkene will be मेजर प्रोडक्ट. एल्कीन्स की स्टेबिलिटी कैसे चेक करनी है ये पिछले वीडियोस में हम समझ चुके हैं. विद द हेल्प ऑफ अल्फा हाइड्रोजन्स वी विल फाइंड इट आउट. लाइक in this alkene we have 6 alpha hydrogens, and in this we have 2 alpha hydrogens. So more alpha hydrogens, more hyperconjugation, less alpha hydrogen, less hyperconjugation. So this alkene is more stable. According to saytzeff, more stable will be a major product and less stable alkene will be a minor product. Now Hofmann, same condition. Alpha, beta, same strong base I am using, alcoholic KOH. Same two type of alkenes I am generating. Same alkenes I have generated. If I am eliminating these two, double bond will come here and this alkene will generate. And if I am eliminating this hydrogen and this X, double bond will come here and this will generate. Now we know this is less stable and this is more stable. Now what Hofmann rule is saying? Hofmann is just opposite of saytzeff. Means this will be minor alkene. Means more stable alkene will be minor and less stable alkene will be major. This is the major difference between these two rules. ध्यान से चेक करो. saytzeff is saying major alkene will be more stable and minor alkene will be less stable one. Where Hofmann is saying more stable will be minor and less stable alkene will be major. Now question arises, when to apply saytzeff and when to apply Hofmann. When X is chlorine, bromine and iodine, then alkene generation will be according to saytzeff rule. And when X is fluorine, alkene generation will be according to Hofmann rule. Now let's understand the reason. Fluorine case, and obviously a strong base I need. Suppose I am using that strong base, sodium ethoxide, CH3, CH2, O negative, Na positive, strong base. This is alpha carbon, this is beta, and this is beta. Now what is special when we have fluorine? Fluorine is highest electronegative atom, means it can attract electrons far much better as compared to other halogens. Its electronegativity is 4, the highest electronegative atom in chemistry. So it can attract electrons far much better than any atom. So what will happen? It will attract electron strongly toward it. This impact will be in every part of the molecule. Now what will happen? This carbon will become highly positive, so it will start attracting electrons from neighbor carbons. Neighbor carbons will start attracting electrons from hydrogen, and this effect will be continue. सेम फ्रॉम दिस साइड. इस इफेक्ट को आप बोलते हो इंडक्टिव इफेक्ट. Fluorine is showing minus I effect and the rest chain is showing plus I effect. Now, because fluorine is attracting electron too much toward it, so it will get partial negative charge. Now these beta hydrogens I will talk about. These beta hydrogens will get positive charges. This beta hydrogen will also get positive charge. Due to these positive charges, this negative particle, means a base, is attacking on them. Now, according to Hofmann, this attack is easy. That's why we are getting less stable alkene as a major product. And to attack on this beta hydrogen is difficult. That's why we are getting more stable alkene in minor amount. Because if we will attack this hydrogen, fluorine will be eliminated, bond will come here, stable alkene will generate. And if we are eliminating this hydrogen and fluorine, bond will generate here, less stable alkene will generate. But in the case of fluorine, this less stable alkene can be easily formed because this attack is easy. And more stable alkene will be less formed because this attack is difficult. Now why? Let's check. This negative particle is attacking on hydrogen because hydrogens are positively charged. Come this side. As we know, due to inductive effect, this whole part, CH3 part, is donating electrons toward this carbon. Now, as these electrons will come toward this carbon, the electrons which were coming from hydrogen side will feel some repulsion and they will move little back. Due to this little backward movement, the positive charge of carbon will decrease. Sorry, positive charge of hydrogen. Positive charge will decrease. बस यही आपका मेन कंसेप्ट है इसके अंदर. Just have a command on it. From this side, electrons are coming. And because this attraction is so strong, the electrons are moving so well due to fluorine. All halogens can't do it. That's why Hofmann rule is generated in the case of fluorine only. This movement is so strong, the electrons will come too much close to this carbon, due to which the electrons which were coming from hydrogen side will feel repulsion and they will move little back. And when electrons will move little back, the positive charge of hydrogen will decrease. Which is not happening on this side, because this side we do not have any alkyl group. Hydrogens are easily giving their electrons toward carbon. That's why the positive charge of these hydrogens are very much as compared to these hydrogens. That's it. This is the main point in Hofmann. The beta hydrogens which do not have any alkyl group in their neighbor are more positively charged, or we can say more acidic, due to which a base is easily attacking on it. But the beta hydrogens in a neighbor side, if we have any alkyl group like this, so this alkyl group will shift its electron due to minus I effect of fluorine toward this carbon, and as this carbon will get electrons, the electrons which were coming from hydrogen side will feel some repulsion and will go little back. And as they are going little back toward hydrogen, the positive charge of hydrogen will decrease. Means this hydrogen is less acidic. बस यही आपका मेन कंसेप्ट है हॉफमैन में. नाउ abstraction of this hydrogen is easy. That's why beta elimination reaction is majorly happening with these hydrogens. And when these hydrogens will eliminate, like one hydrogen from here and fluorine will eliminate, obviously bond will generate between these two carbons and less stable alkene will be formed easily. Whereas the attack on these beta hydrogens, because they are less acidic due to plus I effect of alkyl group, the attack of base is difficult on these hydrogens. That's why after release of these hydrogens, we know which alkene will generate. If I am abstracting this hydrogen and this fluorine, the bond will generate here. But this generation of alkene is very, very difficult because this attack is difficult due to less acidic nature of hydrogens. That's why in Hofmann, the major alkene is from this side, which is less stable alkene. And minor alkene will generate, which is more stable. If bond will generate here, which will be more stable. That's it. This is the reason in Hofmann elimination reaction. One more particle is there which show Hofmann elimination. That is, if at the place of fluorine, if we have this type of nitrogen, quaternary ammonium salts, the nitrogen who is making 4 bond carrying a positive charge will show same type of effect, will show beta elimination, in which the less stable alkene will be the major and more stable alkene will be the minor product. But we will just keep on ourselves to fluorine because we are dealing with haloalkane chapter. So I will just talk about fluorine over here. That's it. This is the end of the video. I hope you got the difference between saytzeff and Hofmann. Thank you very much.